we will work on these ones too today. Or actually, you know what? I put everything together so you don't even need that slip or that sheet out. You can just use the one I'm handing out right now. I forgot that I had put them together. You guys have a nice long weekend. For those of you on vacation, did you have fun? Who was on vacation again? Kathy, did you go on vacation? Next week. Was there somebody else going on vacation? Reese is now, right, this week, I think? Yeah. Nice. All right, guys. So, one of the things about the MCA is that the way they ask the questions is not in line with the way our textbook asks questions. So we did some stuff with distance formula and Pythagorean Theorem this year, but you're gonna notice as I go through questions here that they're different than what we've seen before, so that's why we're spending some time on this. I do wanna tell you too, on Friday this week, did I tell you already that Miss Jerpseth is teaching this Friday? And then they're on spring break next week, but I think she's also coming in Thursday next week, so those would be her 2 times that she's teaching. And then that following week, I wanna say Friday that Rachel, do you know which one Rachel is? She's teaching. So you'll have some different people teaching throughout the next couple of weeks. If there's ever anything that you don't understand and you need me to go over it the next day or ask me questions that day, that's fine. But if anything ever was like, oh, can you just go over that again? Just please ask me. But please be very, like always answer their questions and really help them out as they're teaching. I would appreciate that, okay? All right, so one of the ways that you can do a question like this is you can draw a graph, okay? And what this is asking us for is point M is at 3, -1 right here. And what we want, it says the length from M to N is 5 units. So your point is here, and they're asking us, where else could that point be moved to and be 5 units away? Do you guys get that it could move left 5 units? It could move right 5 units? It could move up 5 units or down 5 units, okay? So you have to take all of those into account. Let's first move it right 5 units. And I'm gonna go 1, 2, 3, 4, 5, okay? So this is 3, 4, 5, 6, 7, 8. So that point would be right here. And it would be 8, -1, okay? Then what I'm gonna do is move that same point back 5. So I'm gonna go 1, 2, 3, 4, 5. And that new point is gonna go right there. And then I'm gonna figure out what are the coordinates of that point. And it's -2, -1. So that's another point, okay? Then they're gonna ask you to move it up 5. Okay, right now it's at -1. So it'd go up to 1, and then it would go, or I'm sorry, up to 0, and then it would go 1, 2, 3, 4 more. So 1, 2, 3, 4, 5. And that would be over 3 up 4. Okay. And then our last point, what would happen there is that you would go down 5. So right now we're at -1. This would be -2, -3, -4, -5, -6 would be 5 down. So this point would be 3, -6. Okay. Now, another thing that you need to know in this, which I think you guys know, do you guys know that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4? Okay. What they're asking us here is what are the coordinates of point N, which can be any of these. All of these are new points N that are 5 units away. So we want the one that's in quadrant 1, and isn't that this one right here, the 3, 4? Because that point is in quadrant 1. So the one that's in quadrant 1 would be your answer. Now if we go down, this one is asking us, what are the coordinates of N if N is in quadrant 2? Quadrant 2 is over here, okay? We want something that is in that quadrant. And do you guys agree we have nothing there yet, right? So here's the thing. If the distance that you have is the hypothesis or the biggest number of a Pythagorean triple, you have to use that in these examples. If you ever need to go from this point to a quadrant kind of diagonally from it, what you're going to do is use a right triangle, and you're going to use a Pythagorean triple. So let's think about this. I'm going to start and draw right here. Okay. Our point N is at, what was it again? 3, -1. Right here, this is N, and it is 3, -1. Okay. What is a Pythagorean triple that has 5 at the biggest? 3, 4, 5, right? Okay. The only time they would ask you to go diagonally is if you have a Pythagorean triple, with the biggest number being the distance. So now, when it's a 3, 4, 5, we could move that over 3 and up 4. And this would be 5. Or we could move it over 4 and up 3. And it would be 5. So you have to take both of those into account. If I go to do this one and I move it over, let's do this top one. Let's move it 3 to the right, or to the left, and 4 up. 1, 2, 3, 4. Okay, that's going to be at 0, 3. Do you guys get that? So what I did here is I made this right triangle, okay? I went over 3, up 4, and then that gave us the distance of 5 between our point and our new point. Now here's a question. Is that new point in quadrant 2? No, why not? Because it's on the axis, it's not in quadrant 2, so this one doesn't work. But I can just tell you in your homework, the one that I'm making a key right now for you guys, both cases work, so you would have to do both of them and put the new points for both. This one doesn't work because it's on the axis, but if it was -1, 3, it would have worked. So now we're gonna try the other case where we go over 4 and up 3. So let's do that. So this was at, I keep forgetting, 2, -1, 3, -1. So 1, 2, 3, -1, that's where our point is. Now, this time what we're gonna do is we're gonna go over 4 and up 3. When we go over the 4, over to the axis is 3, so I have to go 1 more, okay? This is 3, -1, so I'd go over 1, 2, 3, 4, okay? Then, according to this triangle, I have to go up 3. And right now I'm at -1, okay? So I'm gonna go up 1, 2, 3. So it's up 1, 2, 3. And then if I do that, this would automatically be 5, which is the length that we're looking for, okay? So here's the deal. I have to figure out what this point is, okay? And on the MCA test, they won't give you a graph. That's why I'm making you hand draw them. But can you guys tell what point that would be? It's over 1, up 2, right? So wouldn't that be -1, 2? Everybody understand that? Okay, now, I told you guys there's 2 ways to do this, okay? And you decide which one works. So you can graph them like I did here. You can, put your point, count 5 in all 4 directions, and that works. Another way, if you don't want to count, is you could take your point, which was 3, -1, okay? M is 3, -1. And I have to move it 5 to the right, 5 to the left, 5 up, and 5 down. How you can do this is this. You can, the first time, add 5 to the x coordinate, keep the y coordinate the same. The second time, subtract 5 from the x coordinate, keep the y coordinate the same. So I did, what I did there is I moved it to the left and to the right. Then what you can do is you can take that point and add 5 to your y. And of course you can do these in any order. And then the last time I can subtract 5 from my y. And then, so all I did is I added 5 here, I subtracted 5 to the x, I added 5 to my y, I subtracted 5 to my y. And then I can check what those points are. This one's 8, -1, and notice that coincides with this. This one is -2, -1, and that coincides with this one. This one is 3, 4, which is up here. And then this one is 3, -6, and that coincides down here. Once you got those 4 here, okay, once you get these 4, what you would do is just look at where would they be on a graph, which one would be in quadrant 1, okay? And for quadrant 1, that is the one that is 3, 4. Okay, so you think about in quadrant 1, your x and your y are positive, so that is the one it is. So do you guys think it's easier to graph or to do this? This part? Do you? Okay, all right. Now, when I go down to this one, there's also a shortcut way to do this. If you think of a graph and you're at 3, -1, you could kind of just, sketch where you're going because we're going to quadrant 2 right here, okay? If I'm here and I want to go diagonally back here, do you guys get that I would go 3 in the negative direction and then 4 up? what that would tell you to do is take your original point, and if you're going 3 to the left, you would subtract 3. If you were going 3 to the right, you would add 3. Then we know we're going up 4, so we would add 4 to that point. Now 3 minus 3 is 0, -1 plus 4 is 3, and notice that was the point that doesn't work because it's on the axis, okay? And then down here for this one, you would again take your point 3, -1, but this time we went left 4, which would be subtract 4, and up 3, which is plus 3, okay? So what do you think on this one? Does that make sense? So that's another way that you can do it. As far as I'm concerned, you do it whichever way is easier for you, okay? All right, so now let's look here. It says, which of the following points is not 8 units from 2, 5? So I would do this one personally, that shortcut way. I would start with my x and I'd add 8 to it, keep my 5 the same. Then I would start with my 2, subtract 8 from it, keep my y the same. Then for the last 2, I keep my x the same, but I add 8 to my y, and then I subtract 8 from my y. Okay? Do you guys understand how I did the plus 8, minus 8, plus 8, minus 8? So this point gives us 10, 5. This point gives me -6, 5. This point gives me 2, 13. And this point gives me 2, -3. And what I'm going to do is come over here and see which one of these is not one of those. 6, 9 is not. But you all want to check all of them just to make sure you didn't make a mistake. 2, 13 is over there. -6, 5 is over there. 2, -3 is over there. So do you guys get that one? Is that okay? All right. So now let's look at this one. It says a segment has endpoints at 5, 4, and -4, 4. What is the length of the segment? So there's 2 ways you can do this normally. If they're asking for length, you can use the distance formula. That formula would be on the MCA test, and you can use that. Or what you can do is graph it and draw in Pythagorean triangle and use Pythagorean Theorem. When I go to graph this one, okay, the first point is over 5, up 4. The second point is at -4, up 4. So do you guys notice that these are on a straight line? When they're on a straight line, you can just count how far it's going to be. So this point right here was at 5. This point right here is at -4. Do you guys get from 5 to the or to the x-axis? There should be one more in here, sorry. Let's redo it. Okay, so to get over here, you'd go 1, 2, 3, 4, 5. Okay, this would be 5. To get from here to there, you'd go 4. 1, 2, 3, 4. So the total length, you can just think of it down here too. How far is it to get from 5 to the origin? That's 5. How far to get from this y-axis to that? That's 4. And 4 plus 5 is 9. So if there's ever a horizontal or a vertical line, you can just count. You don't have to do distance formula. You do not have to use Pythagorean Theorem. Okay? All right. Now let's go to this page. And this one is asking us to find the distance from point E to point P. Okay, so if we go up here, point P is here, and then did they say E? Is that right? P, oh, point E to point P. So E to P. Now, there's two ways you could do this. You could find the coordinates of these two and do distance formula. E is at -1, 1, and P is at -3, -2. Okay? You have 2 points. You could find the distance formula and do it that way. For this one, I'm going to show you guys using Pythagorean Theorem. So what I'm going to do is I'm going to go across and up to make a right triangle. I also could have gone up right away and across and made that right triangle. But I just did it this way. And what we're looking for is this distance. Now, do you guys get, isn't this 2 across? So this is 2. Then, if I look, this is 1, 2, 3. Okay, so now I have a Pythagorean triple there. I have a triangle where this is 3, this is 2, and I'm looking for this. All I have to do there is do Pythagorean Theorem. So if I was doing that, I could call this my A, this my B, and this my C, and I would go A squared plus B squared equals C squared. A is 3 squared, B is 2 squared, and C is X squared. Okay? Then, if I continue working on that, 3 squared is 9, 2 squared is 4, and that equals X squared. Now, another thing I should have pointed out, this is one of those free response things on the test. So if I were you, if you want the most points, you're going to write every step out. Don't skip anything, okay? And then 9 plus 4 is 13. And then we take the square root. And honestly, let me check if I have this one done. I think we just leave that as square root, but let me make sure. Oh, you're right. Thank you, thank you. So, it's multiple choice. So, here's what we're gonna do. We're gonna draw a number line, okay? And we're gonna try to estimate what square root of 13 is. Do you guys get like 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16? So these are our perfect squares, which we could put under radicals, okay? And we want to pick the 2 that square root of 13 is in between. And it's between square root of 9 and square root of 16. So I'm going to put square root of 9 right here. This would be square root of 10. This would be square root of 11. This would be square root of 12. This would be square root of 13. This would be square root of 14. This would be square root of 15. And at the end, it would be square root of 16. Okay? Now, what we have to do is figure out where would square root of 13 pan out here, okay? If this is 3 and this is 4, we know it's between 3 and 4. Is it exactly 3 or is it more like 3.6? 3.6. Okay, that one's easier than normal. normally they'd have like a 3.6 and maybe a 3.3. So you'd have to think about, is it halfway and a little bit more for it to be 3.6? If it was 3.3, it'd be somewhere over here. So you're just estimating which one makes sense. Okay. This one says the distance from point K to L is 5. Which of these could be coordinates for point L? Okay. So point K, we're using the coordinates from up here. Point K is over 3 up 1, 2, 3, 4. So it's 3, 4. So we're going to take that 3, 4, and our distance is 5. So we're going to add 5 to the x. We're going to subtract 5 from the x. And then we're going to keep the x the same. We're going to add 5 to our y, and we're going to subtract 5 from our y. Okay? When I do this, I get 8, 4. I get negative 2, 4. I get 3, 9. And I get 3, negative 1. Okay? Now, if I look over here, we are looking for which of them could be the coordinates, okay? Notice 8, 4 isn't over here, negative 2, 4 isn't over here, 3, 9 isn't over here, and 3, negative 1 isn't over here. So do you guys know what we'd have to take into account then? Talked about it briefly. Is this the hypotenuse of a right triangle? Yes. Isn't a 3, 4, 5 triangle a right triangle? Okay? So what we have to do is we're going to actually have to go, and to our x and our y, we are going to, because we don't know if this is 3 and 4 or if they're flopped. We also don't know if you're going to go over 3 up 4, over 3 down 4, right 3 up 4, right 3 down 4. So you really have 8 situations to check. But once you found one, you'd be done. Okay? Did you? No? Okay. So, can anyone see one right away? If our point is 3, 4. Oops. And if you can't, that's okay. Okay, now again, you're going to add 3 and subtract 3 from this. Add 4 and subtract 4 from this. Okay? So let's add the first time. Add the 3, add the 4. The next time, let's subtract the 3 and subtract the 4. Okay? And then, just so you know, another thing you would want to do is you would take the 3 and you would add 4, and then from the 4 you would add 3. That's going to be different. From the 3 you would subtract 4, and from the 4 you would subtract 3. Okay? I think that's all of the cases. No, I'd have to do one of each too. Like I could do this one where I add 3 and subtract 4. I could do this one as subtract and that as add. So there's a lot of choices. But let's figure out what each of these are first and see if we've got it already. This one would be 6, 8. This one would be 0, 0. Okay? This one, is that one of them already? Yeah. this one would be 7, 7, and this one would be negative 1, 1. But like I said, it is 0, 0, we can tell that. But if that didn't work, then you would want to go do this one and make one of them negative. Do it again and make the opposite one negative. Then do this one and make one of them negative and then the other one negative. And then you'd have your choices. So there's really 8 of them that you would have. And you want to find the one that matches that. So like to me, that's a tough question for this test. And definitely not something that's taught in a textbook, which makes that hard. All right, again, this is the formula sheet you're gonna have. For right now, we're using Pythagorean Theorem. When you use distance formula, you do not have to have it memorized because that one's kind of yucky to use. And then we'll be using slope and slope-intercept form over the next day or two. And then these two at the end we'll use hopefully before the test. Okay, so let's go to this one. It says, which of the following points, or which of the following are the coordinates of a point that is 4 units away from negative 1, 3? Okay, how much time do we have left right now? It's 15 minutes. I'm always gonna stop at 15 minutes, so if you guys ever notice it's 15 minutes to go, let me know. This is a good place to stop, so let's stop there, okay?